So today is actually Saturday, but it's the day after we finished the first angles lesson. And we really rushed through, as we do a lot. We rushed through, especially right at the end. So I'm going to do a video where I go over the practice problems. I told you I would do that, but I'll kind of put a little bit of review into the first couple of topics we did, but then I'll probably spend a little bit longer on the last couple of topics because then I know in 2 or 3 classes we really rushed through in about 5 or 10. I mean, again, the topics are things you were supposed to already know that you did in prior math, but I get that we don't always remember that, so I'll give you the almost full lesson on mainly vertical angles is the one I'm talking about. All right, so with that in mind, so I'm still just working through the practice problems though. So I assigned page 67 was the first page, and then it'll carry over, but 1 through 41. And I told you there were some problems that were the most important problems that had calculations in them. So I'll identify those when we go through, but I'm gonna work through probably, I don't know, maybe half the problems, something like that, I would guess, in this video. So, with that in mind, first thing we did was just naming angles. There's nothing really on the quiz about naming angles that I can remember. I'm not looking at it. But you do need to understand how to name angles, mostly so when I'm doing the lessons in class, you can follow along so you know what part of the image I'm talking about. If you don't know what part of the image I'm talking about, you're going to struggle to keep up. So make sure you understand quickly what I'm talking about. A good example of that, oh, we need to know what a vertex is. We said that's like the corner of the angle. So if that's an angle there, that's the vertex. The angle itself, we said, is right there. And that little symbol, that little curved marking is how you show that you're talking about an angle in an image. So I went over it in class, but I'll go over it again. We measure an angle way down in the corner. If you had a teeny tiny protractor and you used it, you would get the same number as if you then had a gigantic protractor and you tried to measure the angle somewhere out here. So if you lined up this bottom line and then you measured that line that's kind of going diagonally up, you'll get the same number. So some kids tend to think that because lines are longer than other lines in an angle, that changes the measure. It has nothing to do with how long the lines are. It's this little section right here. That's what matters. And it doesn't matter if the lines keep going way out on the ends out here, doesn't affect that little section down below that I have the arrow pointing to. So that was one quick review thing. Now, quickly, just a couple of answers. So, vertex of angle one. So, one way you can measure or name angles, which I kind of did this way after the fact, is just with a number, like the 1, the 3, the 4, the 2. You'll notice they do not have degree symbols. This is the one exception to always having a degree symbol. But we put the 1s, 2s, 3s, and 4s in there sometimes just to make it faster to name them and easier to talk about. So that's why this one says angle one. I'm sorry, yeah, angle one. Oh, that symbol means angle, by the way. And then if we want to know the vertex, we would look at what angle one is. Let's try to do it with highlighter first. Can't zoom in anymore, but the angle itself for angle one is that right there. So where the number 1 is, it's that little tiny section that we would measure with a protractor. So the vertex of an angle, we said, is the pointy part. It's the corner. I don't really know of any other way to say it, pointy part or corner. So therefore, the vertex for that one would have to be A. So that would be the answer to number 1. Name the sides of angle 4. So again, they're giving you a number. I'll trace it really quick. I probably won't do this in every single problem, but angle 4 would be that angle right there. So if they're talking about the sides, that would be the rays that make it up. So we said a ray has an endpoint, which winds up typically being the vertex of the angle. So they want you to name the bottom line and sort of the top line of that angle. Well, they're lines, so we would have to go back to our naming conventions that we learned in the very first lesson. And we just pick any 2 points on the line. We can switch the order, and we'd have to technically we'd have to remember the symbol. I'm not going to be as picky moving forward in the future on this stuff. If you write something down that's wrong as far as like you leave the arrows off the top, technically it would be wrong. Although in this case, segments might actually be used to name. I think you always use array, but so these are the two answers there regardless. And you could flip the order of the letters. The AC line makes up part of it. The CD line makes up part of it. And that's your angle. Another name for angle 3. So again, we said when you name an angle, you have to use the symbol. There's no other way. I mean, I guess you could write the word angle. It's not technically the way that they say to name it, but if you write angle, obviously people would know you're talking about the angle. So now we said you need 3 letters. These were the rules, 3 letters. And the most important part of that, the vertex of the angle has to be in the center. So the pointy part, the point that is on the very corner has to be in the middle. So if they want to know another way to do angle 3, well, here's angle 3. Actually, let's do that in highlighter so we can see through it. Angle 3 is right there. I guess I could go all the way through there. So I just need to say, okay, well, I need 3 of the letters that are on those lines that I highlighted. I need to, the only one that has to be used is D because it's the vertex, so it has to be in the middle. Other than that, I can pick B, C, or A. I can't say B, D, C. I can't like do that. That's just naming the line basically because they're all on the same line. So I got to use A in some way, but I could say A, D, C, A, D, B. I can flip the order and say B, D, A, C, D, A, but any of those combinations would work. So again, D just has to be in the middle. And then again, you have to use 1 point from one of the sides. So that's one of the sides, and that's one of the sides. I can't use B and C along with D. Hopefully that makes sense. So I'm not going to do any more on that. I think hopefully we get that. Let's see, what's another name for CAD? Again, you could just reverse the letters and make it DAC. You could call it angle 1 to make it short. You cannot call it angle A. I mean, although I will say in this one, you probably can still figure it out. Angle A has a whole bunch of angles coming out of it. There's an angle right there. There's an angle right there. There's an angle right there. If I just say angle A in that situation, you don't know what angle I'm talking about. So you can't just say angle A. Now, if we had this angle, like a totally separate angle, I'm going to use totally separate letters. We had M, N, O. Well, there's no other angles coming out of where O is, where that vertex is. So I could call that angle O because it's obvious that that's the only angle there. But again, if there's multiple angles, you can't just use one letter. All right, so now we're getting into the problems. Man, I said 7 through 11. I don't know why I skipped. I don't know why I skipped 5 and 6. But those are important ones as well. 7 through 11, if you do those, you'd be fine. They're all pretty much the same kind of problem. Figure is just more complex. But it's about a bisector. We said the definition of bisector. If you weren't there or if you're just not remembering it right now, it splits something exactly in half. Well, if something is split exactly in half, if I split 10 in half, I have exactly the same numbers on both sides, the same lengths, the same measures, whatever you want to say. So that's what a bisector does. It can split an angle, it can split a line segment exactly in half, we said. But the key, what you have to know when you hear that word, is you create 2 equal parts, whether it's angles or line segments. So if you say that, if I say, well, let's just go to the problem. I got to figure out. Let me see this if it works real quick. Not the way I love doing it, but all right, that did work. So if I say in the figure, LF and LK are opposite rays, all they're telling you there is that's a straight line. They won't always tell you that. since they just introduced it in this lesson, they're kind of telling you to get you used to that. But normally you can just assume something that looks like a line is a line, a straight line. But that is a straight line. So if you one thing that should be popping in your head already, and if it doesn't, it needs to. If that is a straight line, the measure of that entire line is 180 degrees, which means all of these angles, 1, 2, 3, and 4, they would have to add up to 180 degrees. That's what we've talked about in class. It doesn't have to just be two angles, like we've done this problem a lot. If that's a line and we split it, those two angles have to add up to 180. Well, if I keep splitting it, it's the same thing. All the angles there, I don't care how many I make, they have to add up to 180. I didn't change the fact that I started with a line that was 180 degrees. So now we need to read the problem because I don't think this is actually about that line being 180 degrees. It should be about bisector. Oh, again, you want to go back? We did an example in class. So that's what that means. It means go back and look at example 2. You were supposed to do the check problem on your own, which maybe I'll go back and do that. This should be enough problems there. But if he is straight line at the bottom, and this is what you need to know right here. This is the important information. LG, ray LG, bisects angle FLH. I told you before in class, I like going to the pictures. Colored pencils work great because you can still see through them. Highlighter is good, but it can bleed through. Color pencils don't bleed through. I'm going to treat this kind of like I had colored pencils for you. So if I know they mention LG, I'm going to highlight LG. So there's LG. And I can even put the arrows if I want. They're telling me that that bisects. So again, I need to know that bisects is split. So that line is, or that ray is splitting something in half. And they're telling me it is splitting FLH in half. So I'm going to highlight that. F to L, L to H. Again, all of this is just given information. This is what they told me in the problem. That's the only way I would know it. So now you need, and it doesn't even visually look like this. So this would be one where it's not to scale. But visually, to me, it looks like, let me change to, it looks like this angle here is actually smaller than this angle here. Now, maybe that's just my eyes. Maybe yours looks, maybe it looks normal to you, but for me, it doesn't. So this one, you really, really have to know what all this stuff means. So here's the concept that you need to connect. If I just bisected that green angle, and we've used congruence marks in class, so I'm going to use them here, and I'm also going to give a smaller thickness. That yellow line bisected the green angle, which means these two angles are congruent. That's the definition of bisect. We said congruent means they have the same measure. Could be same length if we're talking about line segments, but we're not here. But it means that they are equal. Same measure, or really just means they're equal. So that angle, and I'll highlight it quickly just in red and get rid of it. That angle there is equal to that angle there. That's because of the word bisect in the problem that they give us. So if I can say that in words, I keep saying this in class, hopefully it's starting to get through. If I can say, well, that angle equals that angle, that's what's going to wind up being my equation. Somewhere I'm going to say whatever this angle is, whatever the measure of it is, has to equal whatever the measure of this other angle is. Again, there could be other types of problems, but that's the way you should sort of be thinking. So now I'm just going to write in more. Yeah, I can't. I wish I could zoom in more. Let me try this. Maybe a fail, but we'll try. I'm not going to save this anyway. So I don't think I can. Yeah, I can't really zoom in. Oh no, I can't zoom in anymore. Anyway, so we'll have to work with that. Oh, did I get rid of all my? Oh wait, hold on. Let me see if I can do this. There we go. Perfect. All right. So now I can do one more. Oh, one more. All right. So now I know those two angles are equal where I have the little red marks. I'm gonna try to write this in. It may not work super well. Oh, here's actually I'll do it this way because this is the way you will see it. So angle FLG, which is kind of the left angle, the angle with the far left green and then the middle yellow. That it tells me right here. It gives me some information. I did not mean to do that. It says something right there. So again, sometimes they write it in the figure, which is what I like to do myself if they don't. Oh, I just noticed that place. Sometimes they'll put it over here on the side like they did here. I'm going to write it in the figure because I like seeing it over there. So I'm going to say, and this is one way that they'll do it sometimes themselves. It's hard to write. So, so this, God bless America. Why is it doing this? Not sure why when it's on pen mode, it's not writing. There we go. So this is the measure of the angle. This is the measure of another angle. It doesn't matter that there's an X and a 17 and a -1. Remember, it also, because of the degree symbol, that's what tells us it's the measure of an angle. Don't forget about that. If it's in the picture or not, they should still be writing that so you know it's about an angle. So with that in mind, I believe it's 14x plus 5. Here's another way they sometimes write the measure of an angle in a figure. They'll draw an arrow pointing into the angle when they don't have a lot of room, because it'd be hard to write 14x plus 5 in there. But 14x plus 5 is the measure of that angle. Well, now if I look, and I would expect this to happen, they're giving me the measure of the angle to the right that has the far right green arrow and then the middle yellow. So this angle right here is the 17x. Subtract 1, I said. Again, degrees. So if you've gone through the concept and you get that how to say it in words, oh, well, then that angle has to be the same measure as that angle. It has to be congruent. Or more specifically, that angle on the left has to equal the angle on the right. That's what bisect means. Then you just set them equal. The angle on the left is this. The angle on the right is this. That is your equation. I've already done videos on algebra, so I'm just going to quickly solve it. I need to get rid of the variables on one side. I'm not even going to try to erase that. So to get rid of it, I subtract it there. Whatever you do on one side, most important rule. Whatever you do on one side, you have to do on the other side. It goes away over there, and that was the whole point. I have 5 still left. 3x subtract 1. Well, to get rid of that. Now that goes away, but then whatever I do on one side, I have to do on the other. I'm going to kind of come way down here. So that's my next step. And then to get rid of the 3, I have to divide because it's 3 times x on the top. So that means x equals 2. And a lot of kids on the one quiz that we've done where you had some calculations stopped there and moved on. But unfortunately, that problem did not just say solve for x. Kind of like, and now I'm going to erase stuff. You can go back if you need to move that. Kind of like this problem also does not just say solve for x. It says find the measure of angle. Oh, the little m, by the way, I've talked a little bit about it off and on, but I say it quickly, so you might have missed it. The little m just means what are the number of degrees? It just means the measure of. So they're not just talking about the shape of the angle or referring to the angle as an object. They want to know what is the measure of it. That's all that means. Sometimes you won't see an M. They'll still just want you to give the measure of it, though. But sometimes you will see the M. It depends on the book sometimes. And I a lot of times won't put the M there. I'll just be looking for the measure of it without putting it there. All right, so if x is 2, I know the measure of Oh, this is kind of a good one. I know the measure of FLH is the green arrows, not the yellow one. FLH is the big angle. So I need to figure out what are the two small angles and then add them together. So this problem also kind of brings in little plus little equals big. So it's a good problem. I like it. I don't remember if I did that on quiz. But just be aware, if I did it, you need to say, okay, well, I need to solve for this angle here and then this angle here, which I'll talk about in a second, and then add them together because they're asking for the big green angle, not one of the smaller angles. I was gonna erase, but I'm just keep it. So anyway, it doesn't matter which one I plug the X into. X is gonna be 2 every time, everywhere you see an X. So I'm gonna plug it in because I'm gonna avoid the subtraction. Not that that's a big deal, you have calculators. So if I want to find the measure of this angle, well, now I know X. So again, like I said, what I just circled is the measure of the angle. We don't know what number that is yet. But once we solve for X, now we can find the measure of that angle. We just say 14 times what X is, because that's what it's telling us to do. 14X is 14 times X. And then we add 5. So 28 plus 5 would give me 28 plus 5 would be 33. So now here's one thing that if you really understand, you might have already thought this. I'm going to need to find the other angle and add them together, we said. But if you remember, that word tells us that both angles have the same measure. They're the same. So I really don't need to find the other one if I did all my math correct. That's the trick, the tricky part, the condition. If you didn't do your math correct, then something might be wrong. But if my math is correct, I should just be able to say, okay, well, the other angle is 33. So 33 plus 33 means it's 66 degrees. Really quickly, I'm going to still plug in the X equals 2 up here. 17 times 2, subtract 1. And sure enough, if you do that on the calculator, 34 subtract 1 is 33. If you made math mistakes somewhere, it's possible to still get a wrong answer if you set the equation up incorrectly or something, but that's a pretty good sign that you got 33 twice. So I'm going to do one really quickly. I'm not going to do all of these. If you want to check your answers, I can just show you the book in class, but I'm just really explaining 2 of them. So next we have, I will do this because now we have this really weird figure. I don't do a lot of this on the quizzes where I give you a whole bunch of problems with only one image, but sometimes there is extra information. So you still have to be able to figure out what information do you not need. What information do you need? What information do you not? So there we go. Just wanted to show everything. So it tells me up here, and this applies to every problem. So this information right here applies to all the problems that follow below. They just didn't want to redraw figures over and over again and keep writing that same information. So they just put it in one spot. So what it's saying is in the figure, BA and BC are opposite rays. So you should now know that just means that's a straight line. So 180 degrees right there. Again, I don't think it's going to be about that. Maybe it is, but I doubt it. Next, BH. So here's a big one. BH bisects, and I'm going to highlight this for sure. You'd use colored pencils if you have them. Highlighter, I guess, works. BH, that line right there, that ray technically, bisects EBC. So I just follow, remember, you just follow the order of the points in order to know which angle they're talking about. EBC. So I know that yellow line bisects those 2 green lines. It also gives me something else, if you'll notice here. It says, okay, there's another line that bisects ABF. Now, this gets confusing when it's all in one picture, probably. So I'm not going to draw anything in because this won't happen on my quiz, and I don't see it happening on anything else. just know when you go to do problems that have to do with basically that ray and that angle, you would need to change what I've done here. Maybe I'll go back and redo it and show you what I'm doing. Maybe I will do one more. Anyway, I'm gonna do one though that only has to do with the yellow and the green that I have on the screen right now. So ABE. So ABE is down here. That doesn't have anything to do with my yellow and green. I'm going to skip that for now. I'll come back to it. I'm just reading to make sure that that one didn't have anything to do with it. So EBH. Okay, so EBH looks like it's going to have to do with it because it basically just retraces some of the arrows I have. That's kind of how I would guess. This will not happen on my quiz. So again, don't worry so much about. Just try to follow along with what I have on the screen. Just struggle. You can go back and try the check problem again if you want to try that. So it's telling me EBH, that one I just had. Hopefully you know which one I'm talking about. Is this measure right here. That is the measure. Don't know the number yet, but that's the measure. I hate when they give you so many things in one drawing, but this can happen on the EOC. They just won't typically ask you multiple problems about it. So this angle right here, nothing, you got to ignore the BF ray. Ignore that. That angle right there, I'm going to try to write it small. It may or may not work, is 6x plus 12. That is the measure of that angle. Again, it's like that line BF does not exist, that ray. I hate it when they try to save room by cramming all that into one picture. Then it says HBC. So again, HBC is a little easier. There's nothing in between it. So that one is 8x subtract 10. Oh, I should put a degree symbol. So that's the measure of those two angles. Now, I've already drawn it in, so I should already know, well, I drew in that yellow ray as a bisector. So I know this angle is congruent to that angle. That's the definition of a bisector. So again, what does congruent means? Well, it means they're equal. They have the same measure. So that's my equation. If I know that angle on the left is equal to that angle on the right, I set them equal. A lot of kids always just default to setting things like this equal. That is not always the case. Just remember that. Sometimes it is, sometimes it's not. Like sometimes we may have to add them up and they have to equal 180. Remember something like that, or 90. All right. So with that in mind, I'll just do the math really quickly. Now I will go back to look at the curve. I did not work. Oh, no, it did work. I don't know. Huh. So subtract six. Why is that not? Not again. What in the world? There we go. So subtract 6x, subtract 6x. I'm going to skip way down to avoid writing in the image. So that went away. That went to 0. 12 is left on the left. 2x subtract 10 on the right. To get rid of the 10, have to do that, which means I got to do that. So I get 22 equals, if I just drawing a line down the middle, 22 equals 2x. So the last step, I'm not going to even scroll down. Last step is divide by 2, divide by 2. So x equals 11. I'm dividing by 2 on the right to get rid of a 2. So if I divide by 2 on the right, I got to divide by 2 on the left. So if x equals 11, remember, check to see what the question says. Pretty good chance that is not the end. And sure enough, oh, you can go back and rewind if you need to see what was there. Sure enough, they are not just saying what is x, they're saying what is EBH. So now I have to go back, find EBH. Oh, well, there's EBH right there, or there's EBH right there, and plug in 11. So 6 times 11 plus 12 would be the measure of the angle. Again, that's why you don't freak out when you see these variables and numbers. Eventually, hopefully, you can solve and find what that number is after you get x. So 66 plus 12. So the measure of that angle should be 78 degrees, which means the measure of this angle should also be 78 if you want to go check it. What would you have? So 88 subtract 10 would be 78. So that worked out. So I'm not going to do any more of those. If you want to do them and check them, I mean, you have the quiz on Tuesday, so really, unless you come by before your class somehow, but for a retake, if you're studying, you can always come back in and check the in the book that I have, the teacher's edition. All right, so let's skip down. I wish there was a better way to scroll down because this is not always. Oh, actually, that wasn't too bad. So I said through 11. Two adjacent angles. I'm not going to do any of that. Oh, vertical angles. I will do that. So I did this lesson in class. It's going to be a longer video than I thought. Vertical angles is one of the number one most important concepts. I said linear pairs, which we spent a lot of time on. That's the straight line thing. And then if I draw another line in, that means this angle here plus this angle here has to equal 180. I told you a lot of times I draw something like that in to remind you of that because a semicircle is 180 degrees. So if that green is 180 degrees, that angle with just one marking plus the angle with two markings has to add up to 180. I'm not going to spend any more time on that, but I am going to do vertical angles. So let's get rid of all of that. And I'm going to need the length of that. So if we have two lines, they cross. There is a concept we actually sort of prove later that says opposite angles are congruent. That angle, let's do this. That angle right there. God, I don't know why it doesn't change it. Oh, what in the world? There we go. So that angle, um, yeah, it's that angle right there is congruent. That's what those little marks mean. If they both have one little mark, it means they have the same measure. These angles, the bigger, wider angles, are also congruent to each other. Again, clearly the skinny one is not congruent to the big wide angle. So that's why one has one mark, one has two. So that is called vertical angle. There is no exception to that. Anytime you see an X in a picture, so there's an X. So that angle is going to be congruent to that. That's going to be congruent to that. Anytime you see an X. There's another X. X there. Again, and by X, I just mean two lines that cross. Doesn't have to be perfectly symmetrical or anything. But again, that angle is going to be congruent to that angle. So this is one of the number one things that comes up in geometry over and over again, along with that concept of two angles on a straight line adding up to 180. I don't see any other X's, but hopefully you get the concept there. So the equations a lot of times, or the problems, will give you something like 3x plus 90 equals 7x subtract 20, something like that. I don't know. And you have to understand, they won't give you anything else. Nothing else. No words, nothing. They'll just say solve for x. You have to understand the angles across from each other or opposite each other, what put it in your own words, have to be congruent because they're vertical angles. Well, if they're congruent, they're the same measure, they're equal. So you just set them equal. So you really, in geometry, you have to know when you can set stuff equal versus when you add them together and set them equal to some third thing. Little plus little is big, basically. I'm not going to solve that out. So the other thing you need to kind of know too, and I'm not going to go over this other than just saying, also in this picture, don't forget those two angles, the skinny angle and the fat angle, the wide angle, they have to add up to 180. So you have a lot of different kind of things, and you're going to see it in a minute anyway, that you can do in anytime you have two lines that cross, two straight lines. But again, you have to understand vertical angles are congruent. Angles across from each other when you have two lines that cross. Oh, shoot, there is one more thing I wanted to say. So this was an issue one year, actually probably several years, and I never knew it. Kids don't always like tell me they're not understanding stuff. Actually, they very rarely tell me they're not understanding stuff. So let me draw what I'm talking about. So there was an image, and I believe it was actually an image, not just two lines crossing. That's horrible, but that's fine. And the kids, and I did not get it, they were struggling with this. They didn't understand, again, two lines cross, right? We have an X in the middle. X in the middle. I don't know why I didn't straighten that line out. Nobody does. Didn't straighten that out either. Two lines are crossing. So we have vertical angles. And kids were not getting this. That angle has to be congruent to that angle. That angle has to be congruent to that. And kids were not getting it. And I don't even know how it came about, if somebody told me or if I just figured it out from talking to somebody. They were confused because they were thinking, well, how in the world can these angles be congruent when this is so much bigger out here? Like, look how much bigger that is. And this one's just little teeny tiny out here. That's why I did the part earlier in the video. We don't measure angles way out there. What matters is what's right down in here. That's where you measure them. That doesn't change if I keep extending lines. I didn't change anything down in here by continuing these lines out. So again, opposite angles are congruent. Doesn't matter what happens way out at the end of the lines. All right. So you're going to do see some problems anyway. So I'm just going forward, trying to move there we go. Oh, I got to go to the left. I'm like, where are all the problems? All right, here we go. So I said 7 through 11, and I said 15. So the next important set was 15 through 17 for problems. This takes into account, and I may not even do all of these. This takes into account what I was just talking about, all the stuff I just said. You need to know right here, I have two lines that cross. Why? Oh, there we go. Straighten down that 10. Two lines that cross. Vertical angles exist. Opposite angles are congruent, which means the opposite angles have the same measure or are equal. That's your equation. 120, I'm going to just do it in highlighter. Oh, actually, I don't know if this will work. What's it? 120 is the measure of one of the angles. This angle, doesn't matter what it says, 2x subtract 10. It has to equal 120. They have to be equal. Don't worry about what it says in there. Vertical angles have to be equal. So if they have to be equal, then I set them equal. That's how I create the equation. I knew I was going to miss it. It's hard to writing and highlighter doesn't always go really slow. That's the equation right there. I'm going to let you solve it. I'm not going to solve it. But again, it's saying the concept in words that allows you to then convert that to an equation. Don't worry about this kind of stuff. X's and numbers. Say the concept first, and then just do what the concept says is true. So next, we'll do number 16. Now, again, we do have lines that cross and opposite angles are equal, but this problem is not about that. There is no measure down here to set equal to 2x. There's no measure over there to set equal to 4x plus 108. So you have to say, okay, well, what else is true besides vertical angles? Again, that goes back to the fact that we have a straight line, and all we really did is just split that into two angles. So think about what that means. Pause it if you need to, because I'm going to go forward. That's that concept. That is 180 degrees to start. I just split it into two angles. This angle here And this angle here, actually, I should color that, worked pretty well. You can see that if I color in the bottom of those shaded sections, forms a line, like it fills in the whole side of that line. So those two angles added together have to equal 180. Again, if I know that angle there plus that angle there has to equal 180, that's my equation. 2x plus I didn't do that. That was weird. I guess I can try to squeeze this in. I really thought it was going to disappear. So 2x plus 4x plus 1. I go slow at once. Oh, 8 equals 180. And you got these are the two main concepts you've got to get down in this lesson. Really, for the rest of geometry, you're going to see them. And then to solve it, first we combine like terms. Again, go back to the algebra if you don't know how to solve it. Then you have a two-step equation that you should be able to solve. It only says solve for the variable, but again, make sure after you solve for a variable, you read the question because you might need to plug it in. So number 17 is a little bit of both. You have some vertical angles that are across from each other. So again, first of all, you have two lines crossing. If you don't see that, anytime you see an X, that's two lines crossing. That means I have opposite angles that are congruent. So those two angles are congruent. Highlighted it. Another hint is I can't solve if I have two variables in one equation. So I can't do anything and start with those two. They're not equations, they're called expressions, but I can't put those in the same equation and solve. Two variables, one equation won't work. So you cannot start with y. Anytime you have two variables, you're always going to start with the equations that only have one variable. So that would be this one and that one. Somehow I'm going to need to use those. So that's also a hint that you need to use vertical angles. Those two angles across from each other, they are congruent. 2x plus 25 is the measure of one of them. Got a degree symbol. 3x subtract 10 is the measure of the other one. If I know they're congruent, that means they're equal. So I set them equal. And really, it's not a pen, but stylus. You solve that out, I'll just tell you, you should get 35. So now here's the trick. This is where it gets tough, and there is something on the quiz like this. That's what x is. X is 35. Again, I need to somehow solve for y, though. 35 is not the measure of an angle. But if I'm going to solve for y, I need to know what this angle on the left is because those two angles together, 2x plus 25 plus y, so now I will write that. So again, you can write the equation on your paper. That's not a bad idea. And if for some reason you get math wrong or you can't solve, I at least know you understand this concept. 2x plus 25 plus y. Dang it. Because again, y is the measure of the angle on the right. I drew a little semicircle. That means they both have to add to 180. Now you can't solve it the way it's written, so you won't get full credit or a C credit even. But I don't know you understood that, and that might be enough to get you to the next letter grade, whatever you're at. Now, though, I just solved for x. Anytime you solve for a variable, you can plug it back in and figure out the pieces of the image, the pieces of the figure. So 2 times 35 plus 25 is going to be the measure of that angle. I mean, that's what the measure is, 2 times x plus 25. So if I do that, what's that, 70, 95. So the measure of that, yeah, 95. The measure of that angle right there is 95 degrees. Now, or I could have plugged it in down here too, I guess, just into this equation and immediately solved. Now, if I know that 95 degrees. So again, that's 95. 95 plus y has to equal 180 because again, they sit on a line. They're linear pairs, the definition we learned. I just solve for y. Subtract 95, and I believe that should be 85. So y equals 85. And y is the measure of the angle, so you don't need to plug it back in because that's the only thing there. And I think it's just like that on the quiz. All right, so I'm not going to do number 7. Oh, that was 17. Sorry, I did do that. So there is one on the quiz that's pretty much like that, where you got to do one variable first and then do the second variable. And you have to understand how to set the equation up for the first variable and the second variable. Let's see. Last piece I think is over here. I mean, there's other problems assigned below, but this is getting to be a long video. It's really the same thing. Yeah, this is the same thing. I have 2 lines, so I don't even think I'm going to do any of these. If you want to see the answers in class, you can. I have 2 lines that cross in every single problem. So that means I have vertical line. Oh, I have a bunch of them here. There's nothing this complex on the quiz, but you would have to, just to let you know, this 3x subtract 24 would only be for this angle right here. It does not go anywhere outside the angle. I don't make it that complex on quizzes, the images, but it could happen on the district or state stuff. So just know when they write that in there, it doesn't cross over the 2 arrow lines. Oh, actually, and you should see this too. I showed you this earlier. It can't cross over because it's telling you right here, this angle is measured as 2y. So they're actually giving you that. The big concept there that I want you to see, if you can't go through and do that one, not a super big deal. It's pretty complex. Just make sure you understand this is a straight line. So again, they don't tell you that, but you have to know when you see a straight line, we can say it's a straight line. I'm going to just show you a couple concepts. I wish I could zoom in more. If that is a straight line, I could do this. I could say, okay, well then that means those 3 angles have to add up to 180. So 5x plus, I think it's 4, 3x subtract 24, and then plus 2y, which we wouldn't be able to solve. Not yet, at least, but those have to add up. I run out of room, so I'll probably write on the other side, but plus 2y, those have to add up to 180 because they all sit on that yellow line. They make that yellow line basically. And if I draw that green semicircle, that shows me, yeah, that is a semicircle, so they have to add up to 180. Another thing you should pull out of that, this 2y right here has a vertical angle right there that is also 2y, that skinny angle. This 3x subtract 24 has a vertical angle that is right there, so it is also 3x subtract 24. So let's trace. I'm going to get rid of that. You can rewind if you need to. So here's the other last tricky piece of the concept. This 5x plus 4 is only right there. But if I trace those lines and continue through, you'll see I have an x. So the measure of the one angle we just said is 5x plus 4. But on the other side of the x, I have a number. That's really where I have to start to solve. So sometimes you got to work your way into what can and you could just set up a bunch of equations until you think you have one you can solve. One variable, one equation is what you're looking for. But that picture is kind of tricky to see where the vertical angles are that you use to solve. So that's all I'm going to do. That should be plenty, probably way longer than a minute to be, but you have a quiz on Tuesday. So, and I think some of you were really, truly planning on coming in to watch it. So I wanted to make sure it was very detailed. If you need to come in early or anything and check answers, you can come into the room and I'll have the teacher's guide out so you can see if you did stuff correctly.